Hello students, today I am explaining important question in Unit 5. Here our question is what the time taken by the workers in performing a job by method 1 and method 2 is given below. So this is the information for method 1 and method 2. Do the data show that the variances of the time distribution from population from which these samples are drawn do not differ significantly? Okay, we need to show that there is no much significant difference between variances of the two population. Okay, that means the variances of the two population almost all equal. That means sigma 1 square equal to sigma 2 square is our null hypothesis. Okay, what the given statement we need to take that is same as for null hypothesis. Okay, so sigma 1 square is what? Variances of the first population. Sigma 2 square is the variance of the second population. Population means here method 1 information and method 2 information. Okay, now sigma 1 means standard deviation. Sigma 1 square means variance. Sigma 2 square means what? Variance of the second population. Here both are same we taken. Now alternative hypothesis is what? Opposite. Sigma 1 square not equal to sigma 2 square. After these two steps we need to write level of significance. In the question they did not give a level of significance. We need to take standard level, that is what? 5%, 0.05. Okay, after h0 h1 level of significance we need to find out calculated value. Okay, your question is what? We need to compare the variances of the two population. That means when we can go to f test. When we can go to f test, t test, chi-square test means here our samples are all small samples. Number of observations are less than 30 and we don't know the standard deviations of the population. That's why we can go to t test, f test, chi-square test. Okay, here our question is what? We need to compare the variances of the population. That's why we can go to f test. So that f calculated formula is what? S2 square by S1 square. Here what I written? Sigma 1 square equal to sigma 2 square. These two are the variances of the population. We don't know the variance of the population. Why? Because they did not give a standard deviation. So that's why we are finding variances of the samples. So for samples we are denoting variances with S1 square and S2 square. Okay, so to find f calculated value we require these two values. So what are the formulas for S1 square and S2 square? S1 square formula is this one, S2 square formula is this one. So to find f we need these two values. To find these two values we required x bar, x minus x bar whole square value. So for that I am drawing one table. So using the table we can find all these values. So first x is nothing but method 1 information. Okay, how many observations? 1 2 3 4 5 6. Okay, here 6 we have. So now add all these values, we get the 134. So x bar is nothing but 134 by 6, 22.33. Next we required x minus x bar, 20 minus 22.33. Next 16 minus 22.33. Like that write all values, you get the x minus x bar. Now x minus x bar whole square is nothing but square of this value. Minus 2.33 whole square value is 5.43. Minus 6.33 whole square value is 40.07. Like that square all these values, we get all these values. Now add all these values, we get the sigma x minus x bar whole square equal to 81.34. So summation of all these values we get what? 81.34. Now S1 square value is what? 81.34. Number of observations are 6. 6 minus 1 5. Okay, that means 16.26. Okay, next method 2 information I written as y. Okay, so here given method 2 information I denoted by y. Now add all these values, you get the 241. Number of observations how many? 1 2 3 4 5 6 7. So what you can get here? 241 by 7 means 34.43. So after y bar we need to what? Y minus y bar. 27 minus 34.43. 33 minus 34.43. After doing all this we get the values this. 34 minus 34.43 means after subtraction minus 0.43. Okay, so like that we get all values. Square all these values to get y minus y bar whole square value. Okay, so why we are finding we required x minus x bar whole square. That means first we required x bar, after that x minus x bar, after that x minus x bar whole square. For same for y also. So that's why we are finding these values by using table. Okay, by using by writing as a table form. Okay, so y minus y bar whole square value over. Add all these values, summation of all these values, we get the 133.72. Now substitute here 133.72. Here number of observations are 7. 7 minus 1 6, that means 22.29. Here s2 square value is greater than s1 square, that's why f value is what? Numerator is s2 square and denominator is s1 square. If s1 square value is greater than, then numerator is s1 square, denominator is s2 square. So after substituting values, we get 1.37. This is what f calculated value. Okay, so after calculated value, next step is what? We need to find out the table value. Okay, here degree of freedom is what? For first one and second one. What given here? Here for n1 value is what? 1 2 3 4 5 6. Okay, 6 minus 1 value is what? 5. And 1 2 3 4 5 6 7. 7 minus 1 is what? 6. Okay, so listen ma, 1 2 3 4 5 6, that means 6 minus 1 5. 1 2 3 4 5 6 7. 7 minus 1 is what? 6. Okay, 5 comma 6. Okay, in the table we need to check what? Row wise what? We need to check v1, and column wise we need to check v2. The intersection of v1 v2 value is nothing but our table value. So the table is what? Level of significance 0.05 na. For 0.05 f table 1 is there, for 0.01 also f table is different. So we need to check the heading. If table is for 0.05, we need to check that table and we need to take the v1 v2 values. v1 value we need to observe in row wise and v2 value we need to observe in column wise. Okay, then the intersection point of the two values is nothing but a table value. So we can get the table value. F table value is 4.95. Calculator value is what? 1.37. Okay, so then f calculator is less than f table value, that means we can accept h naught. If less than, if you get, we can accept h naught, that means there is no significant difference between the variances of the two populations. That means less than, if you get, means we can accept h naught, means the h naught is correct. That means there is no significant difference between the variances of the two population. That means by doing what? Method 1, method 2, there is no much difference between the time taken by the workers. The method 1 and method 2 are almost all same, taking same time. Okay, so this is the problem. One more here, v1 value is what? 5, v2 value is what? 6. So that means row wise we need to take 5 here, 6. The intersection point of these two values is nothing but our table value. Okay, here we got f calculated is less than f table, so that's why we can accept h naught. That means there is no significant difference between the variances of the two population, nothing but two methods. Okay, so okay ma, bye.